So we're not quite to the point that we're going to algebraically find the antiderivative. And what I mean by that is, you know that the derivative of x squared is 2x, right? So the antiderivative of 2x would be x squared. So that whole idea and the formulas we use to find it. So we're almost there. Before that, though, we're going to use the antiderivative. So what they're going to do in this is they're going to give us the antiderivative, and we're going to evaluate the integral using this formula up here. So they're just going to get us set up for definite integrals for now. So if you check out, I was thinking check out and take a look at the same time. That doesn't work. So if you take a look at this definite integral, we're integrating from 1 to 4. Let me give myself some space here. And so if you look at that formula above, that means it's going to be big F of 4 minus big F, or capital F of 1. And the idea is they tell us little f equals big F prime. That's just saying that big F is the antiderivative of little f. So we're going to learn how to find this antiderivative in a little bit, but for now, they're just going to give us the antiderivative straight up. So we don't know what f is, we just know the antiderivative is this, which obviously then the derivative, or little f, would have to be 8x minus 5, because you know how to find the derivative of this, right? Big F prime will give us little f. But the main thing here is just knowing how a definite integral works. We take the antiderivative, we plug in the upper bound, which is what we do here, minus we plug in the lower bound. So with the upper bound plugged in, we'll get 4 times 4 squared minus 5 times 4, minus 4 times 1 squared minus 5 times 1. So what am I plugging into? I'm plugging into big F here. There's the formula. And where did I get this formula from? Right here, right? Fundamental theorem of calculus. And we just evaluate that. So what is that going to be? 16 times 4, I think is 64. Hopefully I'm right. And then that's going to give me 44 minus negative 1, which is 45. And there you go. So that's how you do that. Similar example here. I'll do this one because it has trigonometry and I know how you guys feel about trig. It's integral 0 to pi of g of x dx is going to equal capital G of pi minus capital G of 0. It's very bad looking capital G's. That'll work. So that's going to be cosine of 3 pi minus cosine of 0. And remember your unit circle. So cosine of 0 is 1. And if we go around, that's pi, go around one more time to get to 3 pi. It's negative 1, 0. Negative 1 minus 1 is negative 2. That wasn't even a circle. It was like a bad oval. And that's pretty much it.